Good morning, Ms. Richardson here. I hope you are well. This week we're going to start solving equations, and you will be solving equations for the rest of your mathematical life through middle school, through high school, and beyond. So let's get a good, strong foundation and practice some problems, and I want you guys to feel pretty good about it. All right, so I have sent you some problems. Let me pull those up. And I want you to work along with me, please. So the first question is basically a yes or no question. Is for a solution to. So basically we're going to plug in 4 for the unknown value, which we're calling x, which is our variable. So we're multiplying 3 times, we're substituting 4 for x. So is this statement true? Does 3 times 4 equal 15? Well, no, of course it doesn't. So is 4 a solution to letter A? The answer is no. Now we're going to plug in 4 for x on letter B. And I always put what we're substituting in parentheses. That's a good practice, especially as we go forward and we start putting in some negative numbers. So always put that unknown value or what we're substituting in parentheses. That's a good practice for you. So 2 times 4 is 8, and does 8 minus 3 equal 5? Yes, it does. That is correct. So B, the answer is yes. For letter C, we're going to substitute 4 for x. So we divide first. So 4 divided by 2 is 2. And does 2 plus 3 equal 5? Yes, it does. So the answer for letter C is yes. So that's how we would solve substitution problems. All right. So greater than, less than, and greater than and equal to, or less than or equal to. So you need to memorize these signs. You probably heard about the alligator's mouth is going to eat the larger quantity. But you do need to memorize in which direction they're pointing, which means less than and which means greater than. So if the bigger part is pointing to the left, that's greater than. If the smaller point or the smaller part is, or the closed part is pointing to the left, that means less than. So, and then the next two means if a number is less than or equal to another number, and the last symbol means is one value greater than or equal to another value, right? So hopefully you guys are familiar with those signs. That's not new to you. All right, so let's move on. So I want to know, are these statements true or false? Is 7 less than 10? Is 7 less than 10? That is true. Is 12 greater than or equal to 12? Is 12 greater than or equal to 12? Well, 12 is not greater than 12, but 12 is equal to 12. So that statement is true. And then is 4 less than 1? Is 4 less than 1? No, that statement is false. 4 is not less than 1. 4 is greater than 1. All right, so now the question is 5 a solution to this inequality? So if you have, like letter A, if you have an equal sign, that's called an equation. So A, B, and C are all equations. If you have a inequality, which is what these signs are called, greater than, less than sign, then you're dealing with an inequality. That's what the whole thing is called, an inequality. So we're trying to solve, we're going to try to see if 5 is a solution to each of these inequalities. So we're going to plug in 5 right here. 5 minus 2. What is 5 minus 2? 5 minus 2 is 3, and is 3 less than 10? Yes, it is. So 5 is a solution to letter D. Letter E, 2 times our unknown value. Well, actually, our value is not unknown because they told us the value is 5. So 2 times 5 is 10. And what is 10 plus 3? 10 plus 3 is 13. And is 13 greater than 13? No, 13 is equal to 13. So greater than is not true. It's not a solution. And then we're going to substitute 5 for x again. Well, what is first? So first of all, we got to multiply, right? So 2 times 10 is 20. Uh-oh, I gave y'all an a negative number. Oh, it's not 10, excuse me. Let me back up for a second. That's not right. I don't know why my Georgia Southern accent came out all of a sudden. All right, let's see. Let me change this back to a pen. All right, so now 2 times 5 is 10. So 15 minus 10. Is 15 minus 10 less than 7? Well, is 5 less than 7? Yes, it is. That's true. Yes, 5 is a solution to letter F. All right, now moving on. Which values make 4x plus 2 equal 22 true? So does 4 make it true? I don't know. Let's plug in 4 for x. Oops, that should be a 22. 4 times 4 is 16, and does 16 plus 2 equal 22? Nope. Scratch out the 4. What about the 5? Well, 4 times 5 plus 2. Is 4 times 5 plus 2 22? Yes, it is. So 5 works? Yes. And what about 6? Well, 4 times 6 is 24, and 24 plus 2 is not 22. So the only number that makes that statement true is when x is equal to 5. When x is equal to 5. All right, which is this statement true when x is 4 and y is 3? Well, we're simply going to plug those values in. X for 4, or 4 for x, I should say, and 3 for y. And you're going to do all these types of problems in your exercises this week. Well, 3 times 4 is 12 plus 12 plus 6. Well, 12 plus 12 is 24 plus 6, that is 30. So does 30 equal 26? No. So is this statement true when x is 4 and y is 3? The answer is no. It is not true. All right. Now, don't be worried when they throw in some fractions. You guys know how to multiply with fractions. So we're going to plug in, uh-oh, my variables don't match. That was a mistake. I'm not trying to confuse you guys. I just don't pay attention when I type these sometimes. All right, so this is a multiplication problem, right? 18 times W. Well, what is W? W is 2/3. So how do we multiply a whole number times a fraction? We turn our whole number into a fraction, and then we can multiply straight across, or we can go, okay, well, I can divide 18 and 3 both by 3. 3 divided by 3 is 1. 18 divided by 3 is 6. So now I know that 2/3 of 18 is 6 times 2 is 12. So I've just done this part right here. So 2/3 of 18 is 12. So does 12 plus 4, is that greater than 18? Well, 12 plus 4 is 16. Is 16 greater than 18? No, it's not true. It's not true when W is equal to 2/3. And also, don't forget, if you have this awesome calculator that I told you guys you probably want, there's fraction buttons on here, and you should use those. Use your resources, right? All right, let's move on. Get rid of all this stuff. All right. Next. So Janice is trying to earn $30 to buy a necklace. She has saved $5.25. She earns $2.25 per hour weeding her grandmother's garden, and she earns $5.50 per hour selling buttons at the flea market. Will Janice have enough to buy the necklace if she works in the garden for 2 hours and at the flea market for 4 hours? All right, so Janice wants $30. So she already has, so we're going to start out with, let me change colors here. All right, we are going to start out with how much money she already has. She already has $5.25, plus she's going to earn $2.25 per hour times the number of hours. That's a multiplication problem. Plus she's going to earn $5.50 per hour. It's still per hour, but now it's at a different place and she's earning a different amount. So I'm going to let this equal F for the number of hours at the flea market. So H means the number of hours she's working at her grandmother's. F is the number of hours she's working at the flea market. In order to have enough for the necklace, all right? So let's look at our equation. She starts out with $5.25. She's going to earn $2.25 per hour at her grandmother's, plus $5.50 per hour at the flea market. So now the question is, if the number of hours she works at her grandmother's is 2, if H is 2, and she's going to work at the flea market for 4 hours, is that going to be enough to get her necklace? Actually, we want to know if, so that would be an inequality, right? So if she needed 30, she could earn 30 or more, right? If you have more than $30, can you spend $30? Sure. If you have less than $30, can you spend $30? No. So all of this amount has to be either greater than 30 or equal to 30. Because if you have $30, you can spend $30. So anyway, so we're going to, I'm just going to use my handy dandy calculator. I'm going to type in 5.25 plus 2.25 in parentheses 2 plus 5.5 in parentheses 4, just like I see on my screen there. Use those parentheses. And I want to know what that equals. Well, the quantity of that whole expression right there is $31.75. So is $31.75 greater than or equal to 30? Yes, so she will have enough money. Yes. She will have enough money. That's right. Awesome. All right, moving on. Jack buys 4 sodas per week. How can you represent the total number of sodas he would buy in Y weeks? Well, if he's getting 4 sodas per week, we're going to multiply 4 times the number of weeks. Well, we don't know how many weeks, but we know that Y represents the total number of weeks. So that expression is going to be 5Y. Now, why isn't that an equation? Because we don't have an equal sign. All right, how would I write 6 more than a number? So a number, an unknown number, that's a variable. So you can use whatever variable you want. So 6 more than a number. More than means you take this and you add it to something, right? So a number plus 6. 6 more than a number. So 6 more than 10 would be 10 plus 6. So it's be 16, right? How would I write 3 less than? 3 less than. So less than means we're going to take that whole thing and we're going to put it at the end. Well, the end of what? Twice a number. How do you double a number? Twice a number means to double a number, an unknown number, twice a number. And then it's 3 less than that. Less than is one of those values, and more than, less than and less than and more than is one of those expressions where you put it at the end of something, okay? So that's number 7. All right, let's look at number 8. Samantha and Megan are studying. Samantha studies 2 hours more than 1/3 of Megan's study time. Write an algebraic expression to represent the total number of hours Samantha studied. Well, do we know anything about how long Megan studied? No. So we're going to let Megan's time of studying equal M. Now, we know something about Samantha, don't we? We know how much she studied in comparison to Megan. So she studied 2 hours more than, so more than, that goes with more than, is one of those where you take the 2 and you move it to the end of something. Well, the end of what? 1/3 of Megan's study time. 1/3 of, what does that mean? Of in math means to multiply. So we're going to take Megan's time. We're going to find 1/3 of it. 1/3 of Megan's time. That's what that looks like. 1/3 of Megan's time. And then 2 hours more than that. 2 more than 1/3 of Megan's study time. And that's exactly what that looks like. Okay. Number 9, Jill wants to know how much money she has in total. She has some dimes and some nickels. No, it doesn't say nickels, it says quarters. Write an expression to show how much money she has. So let's say you reached down in your pocket, you pulled out a handful of change, and those coins were dimes and quarters. Well, could you figure out how much money you have? Yes, but you would have to use the value of each coin, right? So she has a number of dimes. We don't know how many dimes. So we're going to let dimes equal D and quarters equal Q. Well, we don't know how many dimes or how many nickels. We don't know how many dimes or how many quarters she has, but we know the value of each of them. So however many dimes she has, each of them is worth 10 cents. So wouldn't we multiply the number of dimes times 0.10 to figure out the value of those dimes? Plus, she has some quarters. I don't know how many quarters she has, but I know how much 1/4 is worth. 1/4 is worth 25 cents. So she has 4. Wouldn't that be 4 times 0.25, which is $1? So however many she has total, we would multiply by 0.25. And that's an expression because we don't know how much money she has in total. She wants to figure out how much money she has. So once she knows how many dimes, how many quarters she has, then she can use this expression to figure out her total value of money. Growing up, my parents received a phone bill every month, my landline at home, because that's all we had. No one had thought even of, probably thought of cell phones, but couldn't imagine it yet. Coffee break, 1 moment. So when I was growing up, we all had landlines, and if you called past a certain area, it was called, it was described as calling long distance, and you had to pay more for those long distance phone calls. Ask your parents; they know exactly what I'm talking about. So if you called, like if I called South Georgia, I would have to pay more to call South Georgia from my home. I would be calling long distance. All right, so every month we got a phone bill, and every month they would charge us $25 for our service. Plus, we would have to pay 50 cents per minute. So per minute, I don't know how many minutes I used in that particular month, but however many minutes it was, I would multiply it by 0.50 and then add my $25 to figure out what my phone bill was. All right, does that make sense? Yeah, your parents know what long distance is. Just ask them. All right, number 11. Some number plus 20 is 55. Some number. What number? I don't know. Some number. Some number plus 20 is 55. So is, every time you see that word, that's an equal sign. Well, guess what we just wrote? Here we wrote an expression, but what did we write on number 11? We wrote an equation, I should say. Now, if I wanted to solve this equation, which is what we're leading into next, I'm going to find the side of the side that has the variable, we want to get that variable by itself. That means we want to cancel what is on the side with the variable. Well, what's on the side with the variable is plus 20. So I'm going to draw this line, and I'm going to do the opposite of what I see. I'm going to do the opposite of addition. What is the opposite of addition? It's subtraction. Well, what if it was subtraction? What's the opposite of subtraction? Addition, right? So I'm making myself a little math problem here. Well, 20 minus 20 is 0. I wanted to cancel that out, and I did. So the only thing left on the left side is an x. And on the right side, I'm going to subtract 55 minus 20, and I get 35. So that sum number is 35. And so the good thing about equations is that you can always check your answer. If x is 35, does 35 plus 20 equal 55? Yes, it does. I know my answer is right, and my answer was 35. Good. All right, so we've just solved our first equation. All right, so now let's practice solving more equations. So look at number 12. The variable's on the left side. So I'm going to draw a line at that equal sign. That means whatever you do on one side of the equal sign, you do on the other side of the equal sign. So I see plus 3. So what's the opposite of adding 3? I'm going to subtract 3 because subtraction is the opposite of addition. So I wanted to get my x by itself. Well, I did that. It's by itself. I got rid of my 3. So now I see 7 minus 3 is 4. And then I can always check my answer. Does 4 plus 3 equal 7? Well, yes, it does. My answer is correct. Number 13, x minus 6. Well, I want x by itself. So what's the opposite of subtracting 6? The opposite of subtracting 6 is adding 6. I'm going to add 6 to both sides of the equal sign. This is gone. X is equal to 21. Then to check my answer, does 21 minus 6 equal 15? Yes, it does. I am correct. Number 14, I want x by itself. What's on the side with x? Minus 7. How do I get rid of minus 7? Or what's the opposite of minus 7? The opposite is addition. I'm going to add 7 to both sides of the equal sign. So this is gone. X is equal to 18 plus 7 is 25. And then to check my answer, does 25 minus 7 equal 18? Yes, it does. I know I'm correct. Now, I know a lot of you really smart kids can do this stuff in your head, but your equations are going to get more complicated. So you do need to do the steps so you're familiar with them. So then when it is much more complicated and we have negative numbers and fractions and all that stuff and addition and multiplication, you know all the steps. And so it's important, even if you can figure out the answer in your head, it is important to go ahead and go through the process, okay? All right, let's look at 15. So 15, I have a variable on the left side of the equal sign. I want it by itself, so I'm going to draw my line. So I see plus 3/4. What's the opposite of adding a fraction? We're going to subtract a fraction. We're going to subtract a fraction from both sides. Everything you write, you have to write twice. So 3/4 minus 3/4 is 0. So I got k by itself. And then I know to subtract fractions, I have to have common denominators. So 4 goes into 8. So I know that if I change my 4 to 8, that will work. Well, 4 times 2 is 8. So what's 3 times 2? 6. So I'm going to subtract I'm going to subtract 6x. No, I'm not. 6/8 from both sides. So 7 minus 6 is 1, and my denominator is 8. So I've solved that equation. K is equal to 1/8. All right, number 16. I want x by itself. So on the side with x is plus 14. So I'm going to do the opposite. I'm going to subtract 14. So that's gone. Got x by itself is equal to 13 minus 4 is 9. Borrow the from the 6, make it a 5. 5 minus 1 is 4. So then I'm going to double check. Does 49 plus 14 equal 63? Yes, it does. My answer is correct. And my answer is X is 49. Number 17, I want X by itself. I see plus 8.6. I'm going to subtract 8.6 from both sides. So that's gone. I'm going to borrow, make that a 5, make that a 2. So 12 minus 6 is 6. 15 minus 8 is 7. And then I bring down my 2. So then double check, does 27.6 plus 8.6 equal 36.2? 6 plus 6 is 12. 8 plus 8 is 16. 36.2, yes. So my answer is correct. All right, what else we got? Anything else? Yep, a little bit more. Oh, and by the way, let me just say this before we move on. The reason I always say find the variable is because sometimes they'll turn the problem around and they will give you something like this. All right, so automatically some kids will start subtracting 25 from both sides, but is that the side with the variable? No, you always find the variable, make your line, and then go, okay, here's the variable. What is on the side with the variable? Minus 11. So how do I get rid of minus 11? What's the opposite of subtracting 11? I'm going to add 11. So you're not subtracting 25, you're actually adding 11. Okay, so be careful. Always look for your variable. Don't just start subtracting whatever the first number is that you see. So be careful on that type of problem. Okay, guys? All right, number 18. Jack, Jill, and Jane together sold 43 tickets for the school dance. Jack sold 12 tickets and Jill sold 12 tickets. How many tickets did Jane sell? Well, we know that there's 3 of them. We know how many 2 of them sold. Well, Jack sold 12. Jill sold 17. How many did Jane sell? We do not know, but we know altogether they sold 43. So what can we do right now? Well, we can combine our 2 constants. So 12 plus 17 is 29. 29 plus 43. Excuse me, plus X is 43. Now I need to solve for my variable. All right, so I want X by itself. So how do I get rid of a positive 29? How do I get 29 down to 0? So even though there's no addition sign in front of that number, I want to cancel out a 29. Well, the only way to do that is to subtract 29 from both sides. So now that number is gone. I bring down my X. So 13 minus 9 is 4. 3 minus 2 is 1. So make sure this 29 plus 14 equal 43. 9 plus 4 is 13. So yes, my answer is right. Jane sold 14 tickets. Jane sold 14 tickets. Joe had $34 to spend. He buys lunch for $6.83, and a shirt for $11.95. He buys a watch with his remaining money. How much was the watch? Well, he had $34, right? He spent $34, all of it. So the money he spent is equal to his lunch plus his shirt, and he bought a watch with the rest of the money. So how much was the watch? We don't know, but we know the grand total was $34. So first thing we're gonna do is add $11.95 plus $6.83, 17. So we know between his lunch and the shirt, he spent $18.78. So $34 is equal to $18.78 plus the watch cost. So now we want our X by itself. So we're going to cancel out a positive $18.78. How do you get rid of $18.78? Well, you subtract it, right? All right, so be careful because you have to line up your decimals. So our line would look a little lopsided. So now we're going to add 2 zeros to $34 so we can subtract $18.78 from it. So we're going to make that a 9, make that a 13, make that a 2. All right, 10 minus 8 is 2, 9 minus 7 is 2, 13 minus 8 is 5, and 2 minus 1 is 15. So the watch costs $15.22. So then you can double check, does $18.78 plus $15.22 equal $34? That's what we're looking for. 8 plus 2 is 10. 7 plus 3 is 10. 8 plus 6 is 14. Carry the 1, I get $34. So yes, I'm correct. So the watch was $15.22. So always go back and double check your answers. Okay, guys? All right, we're done. Look at that. All right, so you'll do those types of problems on today's or this week's lessons. So I hope that helped you. I hope you followed along with me. Hope you guys have a wonderful week, and I will talk to you soon.